Okay, let's see. This is the third part. Let's see now. If we have just added a static route to that destination here. So now, if we repeat the ping, let's see what will happen. If we repeat this ping from this guy, the ping to that network that failed, which is what was that? 225. So if we ping it, we still get destination host is unreachable. Now, and we are getting it from 234. 234 is this 234 is this interface here. So it means that there's a problem that this guy, you see, what that one tells us is that even this guy, even this router does not know where this guy is, in simple words. That is what this one here is telling us. That this guy is the one saying that the destination host is unreachable. You see, we are getting that reply from 192.168.1.234. It simply means, if we were to look at that, we need to look at the IP address that we gave this interface here. The IP address that we gave this interface. So let's just see it. And you can see if you do show IP interface brief, G0/2 as an IP address of 192.168.1.130, which is an address that it should have according to this table here. 192.168.1.130. So let's see if it can ping its own gateway. If this guy, say this guy here, can ping its gateway. So ping 192.168.1.130. So that one shows there's a problem because this guy cannot ping its own default gateway. What should be its own default gateway? It is unable to. No, it shouldn't actually be 130. 130 is the wrong address. Should be, its default gateway should be 230. I should ask it to ping 230, not 130. 230. Let's see. Well, even the 230 itself is unable to ping it. So that's the first problem we need to fix. Because there's no way. Yes?
Did we configure the default gateway for the host, the terminals?
Yeah, let's see. We should have the default gateway is here, 192.168.1.230. So I think therefore, if that is so, it has a gateway, it has a default gateway of 230. So what is the IP address of this G0/2 here? The IP address of G0/2 exactly. This is where the problem is. You see here. It should be 230 here, not 130. So this is called troubleshooting. So if there's no connectivity, then you have to look for where that problem is. So we can see that there's a problem here. So let's say interface, IP interface. G0/2, G0/2. Okay, exit this interface G0/2. And then it should be 192.168.1.230, not 130. And why am I, IP address. And then the subnet mask, which is 255.255.255.248. Do show IP interface brief. So that one has been fixed. We hope that one has fixed some problems that we had. Let's see that thing again. What happens this time round? Yeah, so the problem is fixed there. So that makes you appreciate the troubles that you sometimes will have to go through as a network admin. So that is the issue. When you have to manually configure so many IP addressing, you are bound to make those kind of mistakes. The kind that I made here, that instead of having 230 here, I had 130. And you have seen how we needed to narrow it down to that particular problem and then fix it. So anytime, the beauty of knowing what you want to do is that if it is not working as you expect, you start looking for where the problem is until you pinpoint that problem and try and fix it. So generally, as you configure networks, or as a network admin, network engineer, those are some problems that you'll always encounter. Troubleshooting is part of this life as a network admin or engineer. So up to that point, sijui kama any one of you kuna swali?
So maybe just to ask, at what point do you get timed out and another one destination unreachable?
Okay. So when we get timed out, let's say here, you see the first one here was timed out. You see that request has a number of time that it waits for. If it doesn't receive that reply, then it will be timed out. The reason it is timed out is because before it could get the reply, this host here, this is what device is this PC here, PC1, as you can see here, was still trying to get the MAC address of this destination here. Now, while it is trying to get the MAC address, this first packet was timed out. But after getting the MAC address, then it was able to. We will talk about that process. It's called, there's a topic called ARP, address resolution, where you have an IP address, but for you to talk to that guy, you first of all need to get a MAC address, either it's MAC address or the MAC address of the default gateway. So sometimes that one can result into a packet being dropped. Now, then the other one is this, as you've asked, the destination is unreachable. This is a case where the router receives a packet and that packet has a destination IP address. But when it looks at its MAC address table, it is unable to find that particular destination in its routing table, because we did say that routers make routing decisions based on the entries on its routing table. Right now, look at this. If I try to ping, if I do this ping here, if I say ping 10.10.10.100, it will go to the routing table to look for this route. The router will go to the routing table and look if it knows this destination. Definitely, that router haitapata because there's no single network that has this, whose destination address is this and is in the routing table. So what it will do, it will respond to this PC and tell it that that destination host is unreachable. Do you understand that? Do you see it, Regan?
Yeah, I get it. The ARP part I understand, but I'm like, okay, now if already one host has the same IP address and maybe it's off, so when you try to ping it, you will be timed out and not destination host unreachable.
Yes, that will be just timed out if when it is trying to acquire the MAC address. That one will not be. It won't be because of the destination is unreachable. It is just because the packet has delayed And the reason for the delay always is it is trying to get the MAC address of that particular destination. And then because it takes time to send that request, to get the reply, then the first
For
ping.
for ARP, I understand the first timed out. I understand that one.
Okay.
I'm talking about like for the first one when we were pinging the same network and it was timing out instead of destination host and reachable.
Okay.
Leave alone
Okay.
this one. Yeah.
For example, you see this one is destination, host is unreachable, right? You see this?
Yes. Yeah.
And this one comes from the router. You see, Nana may respond, this guy.
Route. Yeah.
The router has responded to that. But if I ping this, look at this one. You see this network, I want to ping 192.168.1.129.130. I want to ping .131. Look at this. If I ping, I'm on PC1. Let me just make sure I'm on PC1 is this guy. So for this guy, because I'm on PC1, I'm going to ping 192.168.1.3. So if I ping 192.168.1.3, this one will be timed out. All of them will be timed out. Look at this. And then after that, I'll explain why this is this, and this other one, they are all getting timed out. Now, this is where your question is that why are all these ones getting timed out, right? And not destination, host, and reachable.
Yes.
Now, here's the explanation. Here, this one here, this ping here, the packet, this PC looks at this destination. Now, inaona that this destination is outside its network. So if it is outside its network, it sends it to the router. And then the router looks, because you see this is a response from the router. The router looks at its routing table, then it sees it does not have any route to this destination or to this particular host here. So it responds with ICMP type 8 message saying that that host is unreachable. But for this one here, this is a host. In this, the router, Robert, please mute your mic.
Sorry.
But this other one here, this other one, this thing here, this PC1, looks at this address and sees that this guy is in the same network as I am. So it doesn't send a request to the router. It doesn't send a request to the router. So it waits for this guy to reply, but it receives no reply. So all the requests then get timed out. So that is the reason, because this request does not get to the router. This response here up here comes from the router. But in this case, this request does not go to the router. And because this guy is not up, so all those requests just get timed out.
All right, that's what I wanted to know.
Okay. So any other question? Okay, so I think today we can then end there. Maybe I'll share the recordings now that we have recorded. If you want to review, you can review, and then we will see what happens if we again find some time tomorrow. All right.
So,
yes.
So just a question. Did we configure the IP address for the switches, or it took it too much?
No, so we didn't configure any IP address for the switches. You know, the switches do not have interfaces, IP interfaces. These switches are layer 2 devices, so they do not understand IP addressing. So the only time you then configure an IP address for the switch is when you want to manage the switch remotely. You configure what is called switch SVI, switch virtual interface, for remote management of that particular switch. But in this network here, the switches, kazi yao, all the switches do here is to connect end stations, end devices. See, this switch here can connect 24 computers because it has 24 interfaces. Unlike this router, which only has 1, 2, 3 interfaces. So we connect one of the router's interface to a switch, then this switch will connect 24 end hosts. Now, if you are a network admin and you are IT department, yeah, this is the IT department, and you want to manage this switch remotely because it is in a different network, then you create a switch virtual interface, a SVI. And so from this PC, you will be able to log into this switch remotely using that SVI. So in this case, switches did not need to have IP addresses because in this case, switch kazi yake is to just switch traffic or forward traffic to the local hosts, to the different hosts.
So you used it like a hub in this case.
Yes, like a hub. You can say like a hub, but of course, hubs are not used these days. I don't know the last time I met a hub in any network. So a switch is what we use. It's like a hub. Let's just say as you put it.
Yeah, because if for this case we can use it like a hub because if we are to route a packet from the router through switch to the host, then if it is not given an IP address, I thought there could be a problem. Anyway.
No, there's no problem
And
because
even PC getting the IP address, if it is not static, then at least there will be an issue.
no, you see, the thing is the routers are not like hubs. They are nowhere, they are nothing close to hubs because routers, these switches, I mean the switches here, they make switching decisions based on the entries on their MAC address table. If you say show MAC address table here, you see it builds a MAC address table and then it uses the entries in this MAC address table here to make switching decisions. Currently, it only has one entry. So unlike hubs, which will always flood traffic, switches only flood two type of traffics. So switch will only flood what is called unknown unicast. And it will also flood broadcast. Those are the only two type of traffics that the switch will flood. But you see, with hubs will always flood any all traffic, always. And that is the issue. This is the reason why there was need for switches. Because for the hubs, every time they receive any traffic, they will always flood it. The switches will not always flood traffic except for unknown unicast and broadcast. So switches, just like we've said that the routers make forwarding decisions based on the entries in its routing table, switches also make switching decisions based on the entries in its MAC address table. So while routers build a routing table, switches build MAC address table to make switching decisions. And there's a topic about how they build this and how they use it. But these entries in the switches MAC address table are not permanent. They are there for just 5 minutes and then they get flashed out. For example, let me just try to ping. Let me try to ping and then check. Ping the gateway from this guy, 192.168.1.191. And then also ping again from this guy, ping the gateway again. So that you see those entries now will be added in the routers in the switches switching table. So ping 192.168.1.191. Now, if you go and look at the switching table again a second time here, it will add those two entries in its switching table here. You see, at this point, it only had one entry. If you look at it again, you see it has added those other entries. But these entries in this table here will be here for a maximum of 5 minutes. So if they remain idle for 5 minutes, then the switch will flood them out because this MAC address table has a limit. So it can get filled up. And when the MAC address table gets filled up, then the switches will start flooding all traffic. So kuna some attacks. One of the attacks is ARP spoofing attack, or ARP flooding, where attackers will want to send so much traffic to the switch so that the MAC address table gets filled up, and then the switch starts flooding all the traffic like a hub does, and then they're able to capture that traffic and then use it to carry out the attack. But I hope you get the difference between a switch and a hub.
Yeah, I'm good.
Okay. So if that is all, then we can stop there for today and pick it up from there in our next session. So asanteni sana.
All right, thank you.